To wrap up the presentation of question 1, I'm now going to show how to calculate the average velocity and the average speed for this situation. So we'll start with average velocity. We showed in our velocity versus time graph the instantaneous velocities. So essentially that's what we would see if we were to look at our speedometer and count for the direction at any moment. Then that's what we would see, what's shown on the velocity graph. So for instance, if I were to look at 20 seconds at my speedometer, if I happen to have one on my watch or something like that, then I would see a speed of 0.42 meters per second, and I would notice I'm going in the forward directions. So that would be a positive 0.42 meters per second velocity for that. For average velocity, we're talking about the span of the entire trip, and so what the velocity would average for that. In order to do that, we're going to have to use a formula that we've seen before, so I'll bring up a new page for us to work on for that. And so this formula for average velocity can show it in a couple different ways. We can show it as displacement over time. We can also go more explicitly into what displacement is and to show it as final position minus initial position, so our starting position, and then again this is going to be over time. So we can look back at our graph to get some information about this. And so going back to the graph page, we see that we started off at time 0 with a position of 0. That's one of our points in our graph. So that's our initial position. We can also see our final position by looking all the way at the end. At the 28-second mark, we can see that we're a position of 2.5 meters right at the center of the board. So that will be my final position. And again, this took a span of 28 seconds, so that's going to be our total time. So we can come back and plug in those values into the equation. We said the final position was at the center of the whiteboard, which is 2.5 meters. We'll subtract the original position, the initial position, which we described as 0, our position 0. And then we will divide this by time, which we said was 20 seconds. Dividing this out, we end up with about 0.089 as our value. We can see from the units that we had meters on top and seconds on bottom, so we'll end up with meters per second, which is a reasonable unit for velocity. We can also see that we end up with a positive result, and so this is telling us that we are going, that overall in the average, we are going forward at some rate, and it seems to be a pretty slow rate based on what we've shown here. So that will take us through our average velocity calculation. The average speed calculation will be a little bit more difficult. And so we'll return back to the formulas again to think about how we calculate average speed. The formula for that involves taking the total distance and dividing by time. So we have distance divided by time. This is something we can also get from a graph, but it may be a little bit more difficult to do so. So what we can do instead is to think about what we did throughout this entire situation. So thinking about how I walked as described in the situation, I start on one end of the board and I walk all the way across it, which we said is a distance of 5 meters. I then walk another 5 meters across from the second end back to my original end, so we'll tack on another 5 meters there. Since I'm standing in place after that, not moving anywhere, so that will be a distance of 0, after which I walk to the center of the board. Since that's half the distance, instead of 5 meters, it'll be 2.5 meters. And once again, we'll tack on another 0 meters for the time when I am just standing still. So altogether, that takes care of our distances. And again, we will divide by our time, which we showed was a total of 28 seconds. After calculating this out, we'll see that this comes out to about 0.45. And again, the units will be meters per second since we have meters on top and seconds on the bottom. So in this case, we see that the average speed and average velocity are different from each other. One way that we can justify that by looking at the graph, so I'll bring up the graph here, is to show that the velocity at some of these points is negative. We can actually show that that region between 6 and 12 seconds, we have a negative velocity, whereas all the other non-zero velocities are positive. When we're talking about average velocity, negative velocity will cancel out some of the positive velocity, which is why we end up with a value much closer to 0. Whereas when we're talking about speed, all we care about is the magnitude, the absolute value. So that negative 0.83 meters per second as a velocity would be equal to positive 0.83 meters per second as a speed. Because of that, we end up with a larger total, and overall we end up with a larger average speed than average velocity. So that takes us through the end of problem 1, where we have now shown how to graph position versus time, graph velocity versus time, and also address the average speed and average velocity of the motion throughout.